Swayam Prabha. Digital India. Educated India.
There is a need for enhancing space travel technology. Overcoming the current challenges ranging from protecting human health and ensuring safety to improving propulsion efficiency and sustainability requires groundbreaking innovations. We have one such team with us today which has worked in this area and made a mark. Let us meet the team and understand its innovation. So, welcome to the show, guys. How are you doing?
Great, sir. How are you doing?
I'm great. Thank you for joining us today. And so, before we move on further, please tell us something about you and your team.
Okay, sir. So, my name is Krishna Suratwala. I am the team leader of Alpha Century.
My name is Prabha.
And along with us, we are the team of 6 people. Previously, we have worked in the ISRO, where we are doing the internships. For that, the director of NRSC, where we used to work, he told us that these are the problems that we are facing. So he need to find a solution for that, which is finding a solution to make the space travel efficient. So from there, we come up with an idea, which is our SH winning solution.
Okay, so this particular problem statement is unique and not very common. So, can you tell us more about the problem here so that we can understand this thing better?
Okay, sir. So, in this modern world, we can say that many space agencies, especially SpaceX, are working to humanize people on Mars or make life multiplanetary. So, in those scenarios, what happens is we need some kind of technology which can help or enhance space travel efficiently so that people can move from one planet to another in efficient manner. So, with a low risk factor, with low percentage of damage, so there need to be some kind of technology which can enhance the space travel. So this was the entire problem statement that we need to find a solution for.
So, this thing has never been touched upon, not so much in, so much of quantum, not much is, heard about these kind of problems and, people working on such solutions. So, what prompted you, other than your experience at, space organizations, so what prompted you to take this up and work on this?
Some of our team members were working in ISRO, so that's so from there only we got the idea that we can do something in the IT sector that can help astronauts and that can help people to travel from one planet to another. So the idea was guided by the director of NRSC, which was Chauhan sir, as well as some of our guides at the ISRO. So that's how we are motivated to solve this problem.
Okay, so how did you put up the team? Like, you must have thought about like who can be the right people to work on this. So what was the thought going on in your mind? What kind of people would you need? And who are the people who are like, specialized in these kind of areas? So just tell a bit about your team formation. How did it come about? And the roles each one played.
So I am an entrepreneur kind of guy. So I believe in a distributed team where everyone has their own specialties and everyone knows their part and they can play their part as in a very good manner. So we have distributed our whole project into different sectors, or we can say different categories, where each of the category have different domains or specialty that are needed to be handled. So for me, I was managing the EEG part, which is electroencephalography. I was doing research for finding the study related to brain, how brain works, and how we can find something out of brain. Ambika was working on.
I am the front-end developer, like how the idea can be visualized to other. So that's why I done the front-end designing.
Yeah, so apart from us two, there were 4 more members who were doing part like ML engineering. Some of us were doing the generative AI part. Some of us were doing the presentation part. So that's how we have distributed our whole work, and that's how we selected the team, so that the community effort can lead us to a success.
So you collected people from diverse backgrounds and which were kind of a subject matter experts to work on this. So that's great way to form a team for this kind of a problem. So now comes the best part of this conversation, when I would like you to, tell us about the solution that you created. So what exactly did you come up with?
Okay, sir. So the first of all, there are solutions that are related to fuel efficiency for space travel, so that less amount of fuel is required. But our solution is different from them. What we are doing is, instead of making rockets or the spacecraft more reliable or more what we can say efficient, we are trying to make the life of the astronaut or the people who are traveling in the space more efficient. So what we are doing is, we are making some kind of gadgets where we can predict the thoughts of the user, so that the user can be assisted in the harsh condition, in the critical conditions such as space. So for instance, if the astronaut traveling in the space find some kind of error or some kind of problem, so in that scenario, solving the problem by entirely by his own will create some kind of error. It can cause it can reduce the success rate. So what we have done is, we have made a kind of system where we can predict the questionnaires that may have arise in the mind of the user, and answering those questions with the help of an assistant LLM model, so that a full-fledged idea or the full-fledged solution can be provided to the astronaut, so that the success rate can be increased. So for that, what we are doing is, our whole project is divided into three parts. The first one is the EEG part that I was working on. The EEG part is nothing but electroencephalography, which are the small electrodes which are placed over the head, so that we can capture different kind of brain activities from the users. Now, on capturing those brain activities, we can create a predictive model which can predict what kind of brain state the user is having. For example, whether the astronaut or the user wants to concentrate on something, whether the user or astronaut wants to is in relaxation state, or some kind of error or some kind of problem has been detected by the astronaut, or he's surprised by doing something. So this kind of brain state can be predicted using the EEG sensors that are placed over the head. So from this module, we are trying to figure out what's going inside the head, what is the mental state of the user. The second module was the eye gaze module, which is nothing but it just predict that where the user is looking at on the basis of the pupil movement. So right now I am looking at the camera, so it will suggest that okay, the user is looking at the camera, so that our model can get a reference that okay, where the user is actually looking at. Third module is the voice analysis module, where we are capturing the voices spoke by the astronaut or the voices around the astronaut, and trying to figure out what that voices mean and what that noise means. And from that conclusion, we are gathering all the outputs from all the three modules, that is the brain state from the EEG module, the images or the focus of interest from the eye gazing module, as well as the conclusion from the voice analysis module, and passing all this output to a generative AI model, which will generate a question which will depict that what is the mental state, or the question might have arisen in the mind of the user, which will depict the mental state of the user. So this is the main thing what we are doing, and this question will be passed on to the LLM model, which will be fine-tuned by the data which is available by the space agencies like ISRO, SpaceX, and NASA, so that this information will contain different kind of solution debugging way to assist some kind of problem, to solve some kind of problem. So this LLM model will be fine-tuned by the space agencies, and the question generated by our system will be delivered to or fed to the LLM models generated by the space agencies. So this will be a full pipeline, and in this way, the astronaut or the user which is space traveling can be assisted in an efficient manner, so that if any kind of problem arises in the space, he can solve it and reduce the damage and increase the success rate. So this was our whole project.
Okay, that sounds great. Now the thing that comes to my mind is, when you started working on it during the course of hackathon, So when you first came up with this idea and started the first stage of this, you must have gone through the mentoring rounds as well as judging rounds. So what was the first judging round like? So what was the reaction, and was it like going smooth at that particular point, or did you have to pivot after the first judging round? What was the reaction of judges?
Actually, I will say that we were very lucky in terms of mentoring round and judging round, because from the first judging round onwards, mentors were so happy with us that our solution was so unique and it was a full-fledged solution, because we have thought and we have done the research in such a high level that they thought that this approach and this solution is very good, and we should stick with the solution and go forward in it. They said that if you execute it to the fullest, you are 100% a winner. So from the first round itself, we were very clear, and the mentors were so supportive that they always motivated us, and they respected our own approach. They respected our own way of doing work. So that was very great for us, and the all mentoring rounds, all judging rounds were very great. It was a great experience.
Okay, so all the judging rounds went very smooth. That is what you're saying. So was there any feedback which was kind of, you can say, which made you rethink, or which made you, kind of pivot, or, redesign or remodel something?
Yeah, the main problem was arise in the integration part. Our integration approach was somewhat different, where we were making a kind of tree structure for integration, but one of the mentors, the Shubham sir, suggested us, instead of doing a tree structure, we can do a sequential structure of integration, where everything, the output from every module will be used for generating the question, instead of giving some if-else condition kind of thing. So that was the only changes that they have mentioned. Apart from that, everything was from with our plan. It was stick to our plan.
Okay, did you also refer to some kind of a similar body of work at some other place to kind of compare it, or maybe, derive inspiration from?
Okay, so as I told you that I am an entrepreneur kind of guy, so I look forward to Steve Jobs, I look forward to Elon Musk. So I have learned from that only how they work, and upon that I have structured my team, and likewise I have gone on with the hackathon.
Okay, while working on this or before working on this, did you ever refer to any similar body of work, or any other work which you could derive inspiration from, or you can learn something from?
Yes, as I told you earlier that I am an entrepreneur kind of guy, so I was looking forward to Steve Jobs and Elon Musk. So I am very inspired from them and motivated from them. So I always followed their approach of working, their approach of structuring the team, and their approach of going forward with the project. So that's how I structured my planning all the way, and that's how I molded my approach.
Okay, so at what stage is your project now? How ready is it to be, able to get deployed actually? So what do you have to say about that?
Okay, sir. So at this moment, we are at prototype level. We need to make a MVP, which we can launch in the market. Actually, we have talked with many of the experts. They have told us that instead of just focusing on the astronaut or the space agencies, we can start it from the low level. For example, for drivers, for example, for research persons, or some another kind of domain where the audience, or the what we can say, the people are in large amount. So for now we are working for other people, and we are trying to make a MVP out of our prototypes, so that we can start moving into the market. But eventually we get some recognition in the international or national level, we can move forward to the space agencies to carry on with our innovation and carry on with our projects, so that we can help people in traveling in the space efficient.
So what is your vision now? Where do you see this project of yours, this innovation of yours, a few years down the line? So where do you see the success coming from?
So actually, it is a very impactful project, and I think that in next 5 to 10 years or decades, so it will be a necessity for each and every human being on the earth, as the AI is developing in a large by a large proportion, as well as what we can say, the technology is growing day by day. So I think that our product will be a, what we can say, era changing kind of solution where every person will need this kind of solution. And in terms of space travel, this will be a very innovative solution, and I think that each and every astronaut will be using this in the future coming time, as it is very necessary. For example, in the recent time, we have seen that Sunita Williams and some of the other astronauts were stuck in the space. So in this kind of situation, we can have some kind of system which can assist them, which can stay along with them, so that they can solve any kind of issue. They don't feel alone in such kind of issues. So I think that this will be a very innovative, and I think that in next decade or so, this will be a necessity for the humankind. This kind of solution.
This is indeed a very innovative solution and a very path-breaking one, I would say. And world definitely requires it. And I'm sure we will see this innovation being put to use in many arenas around the world. And congratulations once again on winning SIS 2024. You did a remarkable job, and you, I think, had to win this, of course. It was all yours for winning. And thank you so much for joining us today, because it was really very heartening to learn about the work that you've done. It was very we could feel that sensation inside us when we see our innovators, our youngsters working in the area of space and doing something really wonderful. So thank you so much for joining, and wish you all the best for your future endeavors.
Thank you, sir.
The challenges of space travel are numerous, from the extreme conditions of space to the limitations of our current technology. By advancing these technologies, we can make space travel more efficient, sustainable, and safe, paving the way for humanity to explore celestial bliss.